Hello everyone, I'm Sujay Datta. In this video, we will be discussing the remaining questions of the CAT 2024 Slot 2 Quant section. So we already had the first video in which we discussed the first 5 questions. This is the second part of the series, okay, of the video series. So we will move on to the sixth question here. So here it is saying that so Anil invests 22,000 for 6 years with 4% interest per annum, compounded half yearly. So if that is the case, so what we have is for Anil, the amount would be now 4% compounded half yearly becomes 1 plus 4 over 2 divided by 100. So that's 1.02. And 6 years will become 12 periods. So to the power 12. So that is the final amount. Now what Sunil does is he invests a certain amount. So let us call P for 5 years. So that means, and then reinvest this for 1 year at 10%. So that will be the amount after 1 year, one more year. So in both cases, after 6 years, it says that the amounts are equal. So we'll need to equate them. Now dividing by 1.02 to the power 10 on both sides. So this side will have 1.02 squared. Dividing by 1.1. This side will be 20,000. So P will come out to be this times 1.02 squared, that is 1.0404. So that is 20808. So that is the second option. Okay, I hope this was fine. Let's go to the next one. So Amal and Vimal together can complete a task in 150 days. So A and V will take 150 days. V and S would take 100 days. And now it is saying that A starts working for 75 days. Then V works for 135 days. And then S works for 45 days. And then they complete the work. Now we'll try to group them in such a way that we can use these two pieces of information. Okay, so we can rewrite this as when A worked for 75 days, let's say V also worked for 75 days. Now V has 60 more days left. Then V worked for 45 days and S worked for 45 days also. Now V has another 15 days left. Now, if that is the case, let us start with the work to be a multiple of 150 and 100. So let's say 300 units. So the rate of working of A and V together would be 130 over 300 over 150. So that is 2 units per day. And the rate for V and S would be 100 over 3. So that's 3 units per day. So over here, when A and B work for 75 days, so it is 2 times 75, 150 units complete. Here, 45 days, 3 units per day. So 3 times 45. So that is 135 units complete. So that makes 285 units done out of the 300 units that we have. So that means here, this fellow is working 15 units and is completing that in 15 days. So that means the rate of V is 1 unit per day. So from here now we can find out V's rate, we know 1 unit per day. A's rate will now become 2 minus 1, so 1 unit per day. And S will be 3 minus 1, 2 units per day. Now what they're saying is, if A had started the work alone, okay, so now second scenario, A starts alone, V works on every second day. So if I, let's say, write down this, V is working on every alternate day, like that. And S is working on every three. So now the multiple of two and three is six. So if I consider a slot of 6 days, then V has worked on the second, fourth, and sixth, and S has worked on the third and sixth. And then a new cycle of 6 days will come. So in a slot of 6 days, A has worked 6 days and has completed 6 units. V has worked 3 days and has completed 3 units. And S has worked 2 days and has completed 4 units, thus completing 13 units in 6 days. Now you have to figure out how long it takes for 300 units. Now 13 is not a factor of 300, but 13 times 23 takes it very close to 99 units. So 299 units are done in 138 days. We need to do one more day. So on the next day, that is on the 139th day, it would be A who is coming to work because that will be the beginning of the new cycle. And A would have done only 1 unit. So that would have completed the required 300 units of work. And it would have taken them 139 days for that. So the question is the number of days required. So the answer is 139. Okay, let's go to the next question. So the bus starts at 9 a.m., follows a fixed route. One day it traveled at a constant speed of 60 kilometers per hour and reached destination 3.5 hours later than its scheduled arrival time. Note that in the last line, they're asking what is the scheduled arrival time. So let's take that as the variable. So let's take T hours as the scheduled arrival time. So the distance that the bus covered is T plus 3.5. That's the time it took at the speed of 60 kilometers per hour. So 60 times T plus 33.5 kilometers. That's the distance. Now, next day, what it has done is it has traveled two-thirds of that distance in one-third of its scheduled arrival time. Scheduled travel time means T by 3 hours. That means then it is left with one-third of the distance. Let's make that a little short. Okay, so one-third of the distance. And it traveled at 40 kilometers per hour and reaches on time. Now, if T by 3 is already used up and the scheduled time is T hours and he reaches on time, the bus reaches on time, means it must have taken 2T over 3 hours. So what we have here is a simple equation, one-third of this distance. So 60 times T plus 3.5 upon 3 is the speed multiplied with the time. Distance is speed into time. So now 3 cancels out. So we have 3T plus 10.5 equal to 4T. So that gives you T as 10.5 hours. So that means the scheduled arrival time or scheduled travel time duration is 10.5 hours. The bus started at 9 a.m. So from 9 a.m., 10 and a half hours is basically 12 hours would have taken it to 9 p.m. Then 1.5 hours behind it. So that is 7:30 p.m. So third option. Okay, let's go to the next question. So here we have something on functions. So they're saying f of xy is the product of fx and y plus fx plus fy. Okay. They have mentioned that for any prime that you have, you get one. Now we know that every number can be split into its primes. So based on that, we can always express it as a series of combinations of a series of ones. Okay. So since the number is pretty large, 160,000. Okay. So we can start off with a small number and see how the pattern works. Okay. So if you have only one prime, P1, so it is going to be 1. Simple. Okay. Now, what if it's a product of two primes? Okay, we are not talking of distinct primes or identical primes or anything. It's just product of two primes, okay, x and y. Okay. So here it would now become f of P1 times f of P2 plus f of P1 plus f of P2. Why am I even doing this? Because as I said, every number can be split into its combination of primes, right? So it can be a product of two primes. Sometimes it might be a product of three primes. It can be a product of 10 primes, but then eventually it will always be a product of primes. So for this case, it now becomes 1 plus 1 plus 1. So that's 3. All right. For two primes, it's coming 3. For one prime, it was 1. What if there were three primes? Now, for two primes, we already have seen it's 3, right? So we'll not split that. We will keep this together and keep this separate. Okay. So that is f of P1 times P2 times P3 plus f of P1 times P2 plus f of P3. Now we know that this is 3 times 1 plus 3 plus 1. So that comes out to be 7. Now if you observe this pattern, this is 2 to the power 1 minus 1. This is 2 squared minus 1. This is 2 cubed minus 1. So if there are 3 primes, it is 2 cubed minus 1. If it is 2 primes, 2 squared minus 1. If it is 1 prime, 2 to the power 1 minus 1. So we have established the relationship. So when we split 160,000 rather, into its factors. So that's 2 raised to the power 4 times 10 raised to the power 4, right? 16 times 10,000. 10,000 is 10 to the power 4. This becomes 2 to the power 4, 5 to the power 4. So eventually, the whole thing can be split into a combination of 12 primes. Obviously, then the answer would become, so for 3 primes, 2 cube minus 1. For 12 primes, 2 to the power 12 minus 1. Now 2 to the power 12 is 4096 minus 1. So it is 4095. So that is the third option. Okay, so here, these sort of questions, it's best done if you take smaller numbers, see a pattern, and get it done with. Okay, you don't have to analyze the reason behind it, though. It will be a good exercise for you to think why it is coming out in this pattern. But during the test, what is more important is to figure out that the pattern is there rather than trying to understand why it is coming that way. Once you have established that this is what is happening, just go ahead and figure it out, the answer. Okay. All right, let's go to the next question. So we have to sum up this infinite series. Okay. So it's combination of 1/5 and 1/7. So let's just say 1/5 is A and 1/7 is B. Okay. So what you have in this series is A times A minus B plus A squared times A squared minus B squared plus A cube times A cube minus B cube and so on till infinity. Let's just open out. So we have A squared minus AB plus A raised to the power 4 minus A squared B squared plus A to the power 6 minus A cube B cube. Now group the A's separately and the AB terms separately. Now this is an infinite GP with the first term as A squared common ratio 1 minus A squared, right? I mean the common ratio is A squared. So it's the first term divided by 1 minus R. So this minus here the first term is AB. The common ratio is also AB. Now here we can plug in the values. So A squared is 1 over 25, 1 minus 1 over 25. AB is 1 over 35, 1 minus 1 over 35. So denominator here is 24 over 25. So that's 1 over 24. And here is 34 over 35. So that is 1 over 34. So it's 34 minus 24 upon 24 times 34. That's 10 divided by So that comes out to be 5 divided by 408. So that is the first option. Okay, let's get to the next one. So this fruit seller has a stock of mangoes, bananas, and apples, and at least one of each. All right. At the beginning of the day, the number of mangoes make up 40% of his stock. So let's call the stock X. So mangoes come out to be 40%. So that is 2/5 of X. Now he sells half of the mangoes. So now that bananas and apples therefore would make up 3/5 of X. So this is what he has in the beginning. Now what is sold? Okay, during the day, he sold half of the mangoes. So X over 5 sold. Bananas sold 96 and apples sold 40%. Now we don't know what is the number of apples, right? So what we can do is define a new variable. Let's call the bananas B. Okay. So the apples therefore now become 3/5 of X minus B. Or since we are trying to do 40%, so it's better if I take the apples to be A rather. That would be easier to work with. So here now we have apples to be A and bananas to be 3x over 5 minus A. Now apple sold is 40%. So that means 2/5 of A. So left with him. Mangoes left with him 2x over 5 minus x over 5. Bananas left with him, that is 3x over 5 minus A minus 96. And finally apples left with him A minus 2/5 of A. So total number of items remaining with him is x over 5 plus 3x over 5 minus A minus 96 plus 3 over 5A. This is what is remaining. Now at the end it's mentioned that he has ended up selling 50% of all the fruits. So that means what is left is half of what he started off with. So it is half of x. So to simplify this, we just multiply throughout by 10 to get rid of the 2's and the 5's. So 10 times x over 5. So 2x plus 6x minus 10a minus 960 plus 6a equals 5x. So that gives us 3x equal to 960 plus 4a. Now observe 960 is a multiple of 3. So we need to make 4a to be a multiple of 3 also. At the same time, because of 3a over 5, so you need to have a to be a multiple of 5 as well. So we need a to be a multiple of 15. So the least possible value of a is 15. Why are we taking the least? Because they're asking the smallest possible number of fruits. So we need to minimize x as well. So if I plug in a as 15 in this, we get 3x equals 960 plus 60. So x comes out to 320 plus 20. So that is 340. So that's the least number of fruits that the person had started off with. I hope this was fine.